In nuclear physics, chemistry and physics meet. We're going to try to understand the atom from the point of view of physics. This is going to necessitate a little bit of review, excuse me, a little bit of review from chemistry for you. Just some quick things from the periodic table in case you don't remember. There's a link in your notes to one. It's likely the one you used last year, but it might be a different one. When you look at a particular element, let's say fluorine, there's a number at the top, then the symbol, and then the name is written out, and then underneath that there's a number, 18.9984 in this case. These numbers mean different things about the structure of the atom. This number here, the number at the top, is the atomic number. And the atomic number is 100% of the time equal to the number of protons. The number that you see down here, we can call a variety of things. For this one in particular, on the periodic table, it's not a whole number. And the reason it's not a whole number is it's an average of all of the atoms of fluorine that have been identified. We frequently call this the atomic mass. In chemistry, we tend to refer to it as the molecular mass, the molar mass, or the molecular weight. And so if you want to think of it as the same as molecular weight, that's fine for our purposes. In reality, any given atom is either an 18 or a 19 or a 20. It can't be in between. And the reason why is this atomic mass is going to be equal to the number of protons plus the number of neutrons. And we either have a neutron or we don't have a neutron. We don't have a fraction of them. Another way that I could write the same thing is I could write fluorine 19, and that would be telling you that it's an atom of fluorine with the atomic mass of 19. Another way I could show that is fluorine 19 this way, where the number we see up here is equal to the mass. Often, we also would show the 9 down here. For all fluorines are 9, so these two are somewhat redundant, but it'll be helpful in some cases to have that there. This is the number of protons, or in other cases it's going to be useful for us to think of it as the charge. And I'm not talking about the charge of the atom overall, but in this case the charge of the nucleus. The charge of the nucleus, since it has 9 protons, would have a charge of positive 9. The mass as a total is 19. So if I was to ask you how many protons and neutrons in this structure, we would answer 9 protons and 10 neutrons. In a second, we're going to take a look at some sample problems. If this is an easy review for you, you might be able to go ahead and do the practice problems that are in your notes.